morning, everybody. Welcome to class. So today we will wrap up the discussion on the Manchester project that we spent most of Tuesday on, and then we'll move on to one of our final topics for the term, which is around the issue of governance. Before I'll share screen again and just pick up the last little bit of the presentation on Manchester, but I did want to ask before getting started if there are any questions arising out of the presentation on Manchester from Tuesday. If anybody had any comments or questions arising out of that, I did check out there's another couple of comments put into the discussion board, commenting on kind of the desire for such communities in Calgary districts in the future, and also the potential that people think of us actually being able to make the transition or the transformation to build cities in the way that we talk about in the Manchester project. So any comments or questions on that material before I get started on the last few slides? Has anybody been to any of the cities that I spoke about as precedents, and have any comment on your experience in those places? It was, well, if anybody has seen Blatchford and the development that's starting in Edmonton, or experienced Vancouver or Portland, and some of those Scandinavian, Northern European countries, cities that I mentioned. Okay, so I'll be in the sharing screen, but having heard nothing, can someone, yes, so you are hearing me. Sherilyn says, I was thinking about older buildings that will be due for demolition in Manchester. Is there any way to reuse those older building materials? Well, that's typically, they don't get used very much. They end up in landfill. But it is certainly one of, I know there's work, again, at the School of Architecture, Planning and Landscape. Josh Tarrant is one faculty member there who's an architect who's doing a lot of work in reclaiming materials. And of course, it's one of the central points of industrial ecology, or this idea of the circular economy that we talk about these days, is how we, if we do dismantle things, how do we reclaim materials? Make sure that they don't go to a landfill and be covered over in dirt for thousands or hundreds of thousands of years. So it's important, though not a lot of it happens these days. I guess one of the questions around that is the difficulty in recycling some material. So you just think of even a simple product that you might think of where we use glues, right? And we stick things together with quite strong glues. And then you think of taking kind of a piece of plastic and separating it from the metal. Might even be in your iPhone or a computer. A lot of things have different mixes of materials. It might be wood, it might be plastic, it might be metal, and those are often adhered together by glues, chemical compounds that bond. And when you do that kind of a thing, then it makes it very difficult to separate materials. And of course, if you're doing recycling, typically you want to be able to separate metals, separate all kinds of different plastics, separate wood, whatever material that you're dealing with, the different kinds of metals, to be able to efficiently recycle it and put it ultimately back into use. So that's a difficulty in all kinds of ways, right up to the scale of a building. When you take things apart, it depends on how you put them together. So that's the key part here. So a key to a circular economy starts, again, right at the beginning, where you think, well, how am I going to produce or construct this particular thing? It might even, I mean, just think of it at a very small scale. It might even be thinking about where you use screws instead of nails in building houses, for example. I know in people who do renovations and do carpentry, etc., there's always this argument about screws or nails. Where you use screws, where you use nails, and it seems like a kind of a pretty simple argument and maybe a preference. But just use it as an example of if you build a deck on your house, or if your house comes with a deck, if that deck was built with nails, it will be very much more difficult to dismantle than if it was built with screws. With screws, you could just retract the screws, and then the wood is pretty much the shape that it was when you put it down there. But if you did it with nails, then you're probably going to smash up the wood and damage the wood significantly in trying to dismantle that deck. So that's just a simple example, but it's an example that's just meant to convey that to answer your question, not a lot of that kind of recycling happens. We could do a better job of it, but a lot depends on us changing the way that we design and construct things so that they are actually easy to dismantle at the end of their lives. Okay, so that's part of the question, and that's a huge area now, is rethinking design so that it is modular or easily disassembled, and the particular pieces used again. Who is responsible for actually putting these plans, ideas for Manchester into action? So yeah, that's what we've been doing in our research project, and what I'm presenting to you is it's a design research project. So I don't own any land in Manchester. I have no control, or the colleagues that I've been working with have no control over what happens in Manchester. The purpose of the work that I've been presenting is to use design approach and design research to explore the possibilities, and then to put that information before, whether it's landowners. So we have had some interaction with landowners. We had one particular developer who hosted a workshop that we did a few years ago, who was at the time interested in purchasing some of the land down around Manchester. We've had other landowners, current landowners in Manchester, and we've done presentations and had conversations with those individuals, or real estate companies that are interested in purchasing land in Manchester. So trying to convey the possibilities to people who control those processes. Similarly with on the government side, so much of how a city or a district or neighborhood evolves or is developed is dependent upon the rules and regulations in place at the time. And those are set, of course, by governments, predominantly by municipal governments. So when we do our research and we produce the possibilities or the different images of what Manchester might look like in all of the different dimensions that I've already talked about, whether it's the buildings or the neighborhood layout and the land uses that we find across the district, transportation networks, alternatives to automobile transportation, all of those things that we've generated over time, we've made efforts to make sure that there are people at the city, from councillors down to senior managers and not so senior managers and planners and engineers at the city, who are aware of the work that we're doing. So that's to answer your question, Monisha. The work is being done as a project through the university, while I was working at the university, through the Sustainable Calgary, and we try to promote and communicate and advocate for these kinds of changes in Manchester to those who own land, are looking at potentially buying land and developing, and the city, who has control of the regulations of how things happen or what is allowed to happen in a district like Manchester. Okay. All right, so let me share screen and pull up the last few slides, and I could probably elaborate on a couple of those points from the questions as well. Thanks for those questions. So let me start here. we covered a little bit of this territory, but I'll backtrack a couple of slides just to remind us about some of the concepts we were talking about. So if you recall this building here, it's a building on Hastings Street in Vancouver. You can see the port in the background there, which is, as I was saying, is an issue of particular concern now because of all of the road washouts from the heavy storms that they had. That's where a lot of the material that comes into Canada. I think Vancouver is the biggest port, if maybe the second biggest port after Montreal, but perhaps either the first or second in terms of the amount of material that arrives or leaves Canada in trade. So a very important port that's now kind of a bit stuck till the roads get fixed. But anyway, so this building exists right there just beside that port on Hastings Street, which is one of the main streets that runs right from downtown Vancouver through East Vancouver and into Burnaby. And this is an example of that triple mix I was talking about. So earlier on Tuesday, we talked about one of the objectives of the Manchester project is to explore how we put together residential, retail, commercial, that is services that we desire, we require, and industrial to provide jobs, blue collar jobs, as well as white collar jobs, tech jobs, whatever it might be. But how do we get those three kinds of land uses in closer proximity so that we can build communities where we can walk to most of the things that we need? We can walk to work, we can walk to our services, we can walk to the doctor's office, or at least we could easily take a bicycle, and it's with that compact kind of a city, then transit becomes more feasible as well. So that's important. So we talked about, I showed you some images where students in previous courses that I ran were looking at the overall district, that 5 square kilometers, what it might look like in that transition. Remember, we had kind of heavy industry on the east side in the center of the district. And then as you move to the west, you introduce light industry, commercial activity, retail activity, slowly introducing residential land uses, so that by the time you got to the west side, then you're mostly residential, but you still have a little bit of that mix. So that was one way that mix could be achieved. The mix could also be achieved by doing that same thing that I just described in those 5 sub-districts that you remember one of the early slides. We talked about the student course, and we divided Manchester into 5 sub-districts, and a team of students took each of those 5 sub-districts and looked in detail at what the land use actually was on the ground in each of those districts throughout Manchester, and generated all of that data. So we could also take each of those 5 sub-districts and say, for each of these districts, what would it look like if we distributed the mixed use of retail, commercial, residential, and industrial on a sub-district basis? And then in this image, we're bringing it right down to a single building. So you can do that on a neighborhood scale, on a block scale, and right here, we're just saying, here's a precedent in Vancouver where that mix has been achieved at a building scale. So on the bottom couple of floors, you have a mix of retail, commercial, and some light industrial. And then most of the upper floors above that are residential condominium units. So an existing building, it's functioning now in the heart of Vancouver. Why couldn't this be a more standard kind of a construction and ability that we would see in our cities? The one other thing, just while I'm on this point, so I started by talking about the desire to bring all of these different uses in closer proximity, right? And Manchester being an opportunity to see how that might be done through design research, what this project that I'm talking about has been all about. So part of the reason for that are it's the reason we don't have triple mix. We used to have triple mix, say 150 years ago. So at the dawn of when we began to do planning, or at the early age of the Industrial Revolution. Remember, when we talked about the Industrial Revolution, we talked about places like Manchester and London and other cities that were not particularly pleasant places to live in that period of time. There was heavy use of coal, the first real fossil fuel to be used ubiquitously. So there was a heavy use of coal in cities. So these places were not very healthy places. There was a lot of respiratory disease and issues because of the heavy use of coal in cities. They weren't very pleasant places from a social point of view. You didn't have universal health care. You didn't have unemployment insurance. Those images I showed of the kids who were basically commandeered by unsavory characters to set up little crime syndicates as a way to survive. So very unpleasant conditions, and particularly that is why. So in those cities at the beginning of the Industrial Revolution, you would have seen that mix. So people would have typically, the workers would have typically been living very close to the factories in not very pleasant conditions, what we would refer today probably to as slums. But that's the way things started. And it was through the intervention of planning and through the intervention of public health that began to change, and people realized, well, this is not a very healthy situation. So over time, the decisions were made to separate those dirty polluting factories from where people lived as a public health issue for the most part. And land use planning emerged as a profession in that period of time as well. So over time, that separation became a hyper separation. And we use the automobile as a way to achieve that, because now we said we have automobiles, we can put factories way out here on one side of the city, we can put big shopping malls and big box here in another district of the city, and everybody can live in these suburban neighborhoods that are just nothing but residential, etc., because we have the automobile to move us all around. And now we've come to full circle in that kind of argument to say, well, that's not a very good situation, because now the biggest polluter that we have is actually the automobiles that we're using to move through the landscapes that we've created. And so the conventional or the newer thinking in planning and in urban design now is to how do we bring these uses back together in close proximity, so that we don't have to require or to rely on the automobile and the very expensive infrastructure that goes along with it. And that's one of the ways that becomes more possible is when we talk about the industrial ecology approach to industry. We're getting rid of waste and also getting rid of pollution. So the idea is, as I described earlier, you have industries where the waste, so-called waste of one industry, is actually the raw material that the next industry requires. So you build waste out of the system. And similarly, you build toxins and pollution out of the system. So what you attempt to do in an industrial ecology model is, it goes back to how you construct things again. To answer the question that came up at the beginning there, you think right from the start about how do we construct these products that we're manufacturing? How do we construct the manufacturing, the plant where things are manufactured? How do we manufacture our homes with the view of minimizing or eliminating toxic materials in those processes? And in many cases, the glues that I talked about that make it difficult for recycling are also the kinds of things that make it dangerous, especially if you think of flammable materials or the situation of fire. That's actually one of the most dangerous elements of firefighting these days, is the toxic materials that are generated when some of these materials that we've used have burned. So that's all to say that is one of the strategies. So from a planning point of view, we've decided that it's important not to have to rely on the automobile. Let's bring these things together. When you pair that with industrial ecology, then you begin to see how we're able to now bring industry back into close proximity, bring those jobs back into close proximity, because we're beginning to do it in a way where we're not generating waste or pollution. Okay, so those neighborhoods where people will live and there are jobs in industry are no longer dirty and dangerous and polluting. That's the idea here, the concept that we're trying to work on. So that's a long explanation for that slide. We haven't even got to the new ones yet, but anyway, there we go. Okay, so we talked about, again, at a building scale, being able to now, a precedent in Seattle where this building collects and recycles all of its own water, and it collects all of its own energy, heat energy through passive solar and electric energy through photovoltaics on the roof, solar panels. So again, this is possible. It's minimal extra cost. And why can't we not begin to or legislate or regulate the requirement in our building codes for all buildings to be built to this sort of a standard? And the N3 building, which is down in East Village, again, this is a building where we have eliminated the automobile, and we've eliminated the need for somebody who purchases a condominium in this building to pay $30,000 to $50,000 for the parking stall for that condominium, whether you own an automobile or not. why can't we begin to see that all buildings could be built this way and all neighborhoods can be built in such a way that you don't actually need that automobile that's designed out of this particular building. And then we talked about the difference between the LRT, which tends to be a step up from a streetcar, which is pictured in this image. So the LRT, which we're all familiar with here because it's the major transit system that we have in the city. And you can see in some of the newer stations, and as we redevelop stations, we have this intense nodal development where we have a very compact development, usually mixed use with retail and commercial and residential in close proximity to LRT stations, and typically towers that are built, double-digit story towers that are built in proximity to the LRT station. So you get that very intense nodal development, and then between stations, not so much. Whereas the streetcar, what it offers you, it's first of all, it's probably about 10% the expense per kilometer to build streetcar. It services more as not a citywide system, but as a system that services neighborhoods or smaller districts like the Manchester district to help people move around within those districts. And it creates the pattern of a nodal style of development, which you can see on this street in Seattle, where the development now is not concentrated on these single nodes with not much in between the stations, to development that really runs linear along a street and creates kind of a nice main street environment, which again is mixed use with commercial and retail and residential, but not typically the high rises that you would find in an LRT or a nodal style of development. Anybody who's been to Vancouver can see really some SkyTrain. So the SkyTrain would be on the same kind of scale as an LRT. It's a citywide transportation system, pretty expensive to build. And it's, if you've been to Vancouver lately, you can see that they've really ramped up, even compared to Calgary, the intensity of development in places like the Brentwood station in Burnaby, for example, that I'm familiar with, is very, very intense development. So in the Brentwood station in Burnaby, the station is right there. And then as you walk, you don't even have to walk off the platform and you walk into a major shopping mall. And then within 100 meters, you have about, well, say within 200 meters, you might have 6 or 10 buildings that are over 20 stories tall, mostly residential. So very intense style of development. Whereas the streetcar allows us to make this linear kind of development that I've talked about. So and that's what the proposition that we make for Manchester is, to use the streetcar to build and support the development of these main streets, and even, compared to the picture that you're seeing here, minimizing the need for or the access of automobiles is even more than you would see in this picture, and being able to do that without the context of all of the proposed design changes that we're talking about in Manchester. But in any event, the bottom line in Manchester is that we've been proposing, and again, some of the students worked on ideas where you have a grid of streetcar lines. So maybe a couple of streetcar lines that go east-west and a couple of streetcar lines that go north-south that give you coverage across the district and allow people to move. The other thing that's really interesting about the streetcar network that we proposed early on, and we started looking at the feasibility of it, and then we discovered that in fact this is happening in places in Europe already, is to use the streetcar network, maybe even the LRT, as doubling it as a goods moving system as well. So not only moving people, but also moving goods. And what that does in a place like Manchester, and in general in industrial districts, it allows you to start moving away from one of the most difficult elements of harmonizing, say, residential and pedestrian traffic with an industrial area, and that's the large trucks that usually circulate, that we've become dependent upon in industrial areas, and in Manchester, no less than most other industrial areas in our city and across North America, really. But there's a lot of work now going into exploring the option of going back to a rail system, and maybe using a smaller kind of a system, like a streetcar system, rather than heavy rail, to actually move goods. And maybe you imagine the logistics where goods movement happens in the off hours, when there's not a lot of need for commuters to be using LRT or streetcar systems. Maybe then those lines are used to move goods and materials throughout the city, or into the city, into districts where they're used, into into manufacturing establishments, etc. So a very neat idea as well. And this is an image of exactly one of those things happening. This is the Volkswagen assembly plant in the center of Dresden in Germany. It's a very kind of high-tech looking assembly plant for one of the high-end VWs. I can't remember the name of the model of the car, but anyway, it's assembled in this plant. It's also kind of an industrial tourism. So a lot of people come here because they've put a lot of effort into making it an attractive place, making it a place where visitors are welcome, and visitors can come and see the industrial manufacturing processes involved in that in the automobile manufacturing industry. Now that doesn't jive with our desire to make automobiles tertiary to our existence in cities. But in any case, the point is that this is an example of a significant manufacturing establishment in the middle of the city in Dresden. And this is served, the materials that come into the plant to be assembled come into the plant via streetcar. So very interesting. And then there are several, at least 2 or 3 other European cities who are now experimenting in a more general way with moving goods and materials via streetcar rather than via heavy trucks. But this is, again, a precedent. It actually exists in Dresden, where the materials for this particular manufacturing plant arrive at that plant in the heart of Dresden via streetcar. The next couple of images I want to show you is some more of the work that we've done in Manchester with architect partners. There's one group in particular called Spectacle Architecture, and they're both graduates of the School of Architecture, Planning and Landscape at U of C. But we worked with Spectacle and sent students to, again, go at the ground level in Manchester and begin to create images of, with all of these ideas that we've just talked about, try to incorporate these ideas and produce images of what it looks like in Manchester now on particular streets and what it could look like in the future. This is 58th Street, which is one of the largest, busiest streets that runs through Manchester, east to west. A lot of people use this street to get to Manchester from the west and to leave Manchester or go via Manchester into districts to the east of towards Deerfoot Trail, for example. So a very busy street, not very friendly at all for pedestrians, as you can kind of imagine as you survey what it looks like here for yourself. And it just so happens that the red tower that you see on the right, the left-hand side, is one of those half a dozen towers, residential towers that exist in Manchester now, which are pretty much adjacent to McLeod Trail. And if I'm not, no, this wouldn't be McLeod Trail where we're kind of standing to take this image, but it's maybe a block from McLeod Trail. But anyway, those towers exist there, those residential towers, just a couple of blocks from this intersection. And some of those towers house social housing, units for social housing, including new immigrants with young kids. So there's a lot of activity in this district of people pushing baby strollers and kids in hand. Not a very safe environment for those people, and people with disabilities. There's particular units that are built into some of the social housing there in Manchester that are custom made for people with disabilities, people in wheelchairs, etc. And again, those people have to move from that residential district to, if they want to get to the LRT in the Chinook LRT station, they have to cross this street. If they want to get to the Chinook Mall for shopping, they have to cross this street and McLeod Trail. So not very conducive to pedestrian life. So this is an image of how that street might change. So you see that there's wider sidewalks, there's bicycle pathways, we've narrowed the streetway and made it kind of a what people refer to as a Danish concept called the Wunderf, which means a shared street. So what that means is that you treat, so you can see the bricks here on the street. So it's a different kind of a treatment from a design point of view that tells drivers this, slow down here. This is a different kind of a street. You reduce speed limits, you make the street narrower, you put in street furniture and trees, and that automatically signals to drivers that this is a place where you have to slow down. And then it makes it possible for it to be a share street in the sense that you don't have a pedestrian doesn't necessarily have to push a walk light and wait for a green light to walk, but the street is such that it is safe to have it shared with whatever vehicles may be around, but also giving space to pedestrians and to bicycles, etc. And you can see the introduction of mid-rise buildings, 6 and 7 story buildings that would have commercial on the bottom and residential on the top, etc. So that's one example of potentially how a place like Manchester would transform, using the skills of design professionals to try to help us to imagine that and to implement some of the precedents that we're talking about. There's another intersection at, I think this is 42nd. It's close to the NMAX headquarters, and it was a former go-kart site. What we were looking at there, kind of at the other, across from the intersection, was a site that used to be a go-kart park. Doesn't exist as that anymore. It's just kind of abandoned now. But the truck that you see is driving on a utility road. So this is a road that runs, you may recognize it from your own time spent in Manchester, driving through Manchester. There's a gravel utility road that runs pretty much through north-south through the entire length of Manchester. And it's, just an unused road that every now and then a transit truck or something like that, well, usually transit trucks or utility trucks in the city would use for access to various things. And this is the kind of treatment that we've talked about here. So this, again, turning this into a major node where now you have lots of pedestrian infrastructure, lots of bicycle infrastructure, and you introduce, again, mid-rise mixed use kinds of buildings. You can see on the left, they've implemented a bicycle parkade. You can see that kind of circular building there on the left, where now that's a major bicycle parkade. So this is a major node where you can get to this location on your bicycle and then leave your bicycle and take the train to wherever you might want to go. So again, and just another imagining of how these environments might transform. And then finally, this is, so that previous one, the core idea here was what happens with what used to be that the go-kart track, right? And you can see now it's a plaza. You have this place for bicycle storage, and you have mid-rise mixed-use buildings in that space. And this is another image similarly of that utility road. You can see the utility road more clearly in this image, and you can see, as you look around, you can see the lack of density, a lack of intensity of usage. You see some big box looking buildings in the distance. You can pick out that there's lots of parking in the distance there associated with those buildings. And this is a rendering of what that could be. So the idea here is, let's take this utility quarter and what could we do with it? Well, this could become one of those pedestrian streets that I talked about last time in that street palette that's available to us. One of the students worked on introducing different kinds of streets that could be used by city planners. And this is a pedestrian street, could also, and pedestrian bicycle, as you can see in this image. So you've got the LRT, and then beside the LRT, now you've taken that utility quarter, which is very unused, and made it into something. And this could be, consider this as part of what could be one of those walking main streets. The same concept that you might remember that we talked about when I introduced the Franklin Spurline project a couple of weeks ago. So the same idea here. Let's take this unused piece of infrastructure. It's already set aside because it's this utility road right through the middle of Manchester. Let's make it into something. And then let's make some urban gardening and have allotment plots so people can arrive here on the train and they can do their gardening if they, or if they live in a condominium where they don't have gardens, etc. But just making these active spaces and minimizing the need for the automobile in these circulating spaces that we have. So just one image of what could happen in Manchester, and especially that utility quarter to me is one of the kind of the gems in Manchester that could really be a game changer if we took the time to make some changes in a place like that utility quarter and make it into something like this. So that's the end of the presentation pretty much. So that's some of an idea of the work that we've done in this living lab in Manchester. You can also go on the Sustainable Calgary website, and in fact all of the design work over the past decade for this Manchester project. All of the student projects that have been done, multiple courses, et cetera, the work that we've done with our professional partners in spectacle architecture and other organizations is all contained on that website. So you can get a good sense of all the kinds of work that's been done to present ideas of where we could go with Manchester as a way to achieve existing policy and as a way to achieve this idea of a low carbon or no carbon city or post carbon city or net zero cities and city districts. Okay, the last slide, I'll just, these are just some of the, so this is a, you know, what we've been working on as a research program, and there are many parts to that program. I've talked about some of them. And then there are other parts of the program that are still, you know, in terms of our strategy or entire program over time, kinds of research that needs to be done to make these visions of these industrial areas and transforming them into a reality. We talked a lot about the mixed use element as we go down the list here: retail, commercial, residential, and industrial mixes. Regulatory framework, when we did a lot of workshops with different stakeholders as part of this project, and we asked people to take a look at the imagining of what could be in Manchester and help us think through what could be the problems in getting there. And one of the main problems that people identified was the regulatory framework to facilitate innovation. So what we find in large cities these days is that the planning framework and the planning regulations have kind of become ossified, and they've been baked into the system over decades and decades to really reproduce an automobile-oriented city and a low-density city and a city where we don't mix uses. So there are all kinds of regulatory regulations and laws in place that forbid us doing something else. So forbid you from being able to do things that minimize car access, or forbid you to creating more dense environments, or forbid you from bringing industrial in close proximity to residential, et cetera. So that's part of the issue. Another one is looking at scale of all kinds. We talked about the scale of where that mix happens, that triple mix. So it could be just imagining that mix, it happens across the entire landscape of the district, across the 5 square miles, square kilometers, or as we demonstrated, we could also talk about that mix happening in a single building. Similarly, we think one of the research pieces that needs to be done in more detail is thinking about scale in terms of energy and water infrastructure. So is it more efficient to try to provision water at a district basis, or to just tap into the existing water infrastructure of the city and provide water that way? Or is it more efficient to start thinking about harvesting water, and that each building and each building lot becomes its own water harvesting, much like the building in Seattle. And instead of having to build expensive underwater water infrastructure that feeds off of the citywide system and brings water from long distances into the district and necessitates the implementation of hundreds of kilometers of underground pipe to do that, is it more feasible to just harvest water off roofs and avoid the need for some of that really expensive underground infrastructure? A research question to be answered. Similarly with energy, does it make sense to try to implement kind of district scale energy? So district energy is something that's becoming more popular these days, and actually in Scandinavia, district energy is the way that most of the energy in cities is provided in places like Copenhagen and Stockholm and Amsterdam. So does it make sense to build a district energy plant that would provide energy to the entire district of Manchester? Or does it make more sense to think of every building as its own energy generator, as the Seattle building demonstrated? So again, these are research questions that still remain open questions in terms of how we build into the future most efficiently. Non-auto transportation systems certainly need to be more research done into how to actually make that happen. Affordable housing, so introducing things like the land trusts that we talked about. How do we get more cooperative housing, which is another form of housing that Jeff talked about, or co-housing, Prairie Sky co-housing in Calgary is a good example of that. So how do we ensure that when all of this kind of development happens and it becomes a really nice place that people want to be and they start bidding up house prices, how do we ensure that affordability is baked in? Goods movement logistics, I talked a little bit about ideas like moving goods on rail. That's just a very new idea that's starting to happen in some cities in Europe, but certainly lots of more work to be done to see how that could be feasible in a place like Calgary. Construction logistics is an interesting one. If we think of large-scale redevelopment like Manchester, 5 square kilometers is very, very large. Can we assemble all of the materials that we need, or construct all the materials we need inside the perimeter of the district, so we don't have all of the headaches of having a lot of goods movement, of a lot of big heavy trucks coming and going over a construction period that could be decades long, and creating lots of logistics nightmares for an area that's in the heart of the existing city. So is it possible to do that, to actually bring the raw materials in to the district and then build the district kind of from the inside out without having a lot of conflict that beyond the borders of the district? That's an interesting question from an engineering and logistics point of view. Effective and cost-efficient land remediation. This is an industrial district. There are a lot of issues around land contamination because of the industrial enterprises that existed there over time. So that's another research question. How do you efficiently do land remediation to allow that triple mix to happen, to make it safe for people to live in different parcels of land there? And then finance, innovation, and land assembly. The last two are also interesting because it is very difficult to assemble the amount of, you can imagine that this is a very, very big, very expensive project. So we need also to think about innovative ways of financing this kind of development and innovative ways of assembling the land. So most of the precedents that I talked about last Tuesday, whether they're in Vancouver or Portland or the European precedents, most of those precedents, and the Blatchford precedent in Edmonton, most of those precedents come in places where most of the land is either in a single individual's hand or single corporate hand, more often publicly owned. So there's a single or very, very few owners, which makes it easy for land assembly because essentially it's already assembled. If you don't have a situation where there's only one or a very small number of land owners, then having this kind of a visionary project becomes very difficult because you have many, many different landowners with many, many different agendas, and it just becomes very much more difficult. So that's another research question in places like Manchester, where the land ownership is actually very, very dispersed. There's a significant amount of publicly owned land, but the majority of the land is in private hands, and a lot of different private hands. So then that becomes a research issue. How do you assemble land or get everybody lined up so that all of the landowners, or the majority, say, yeah, this is a good idea, this is going to be good for me, and I support moving in this kind of direction. So that's another research. So all kinds of interesting research, if anybody's ever thinking about going into graduate school, lots of really interesting ideas and research that needs to be done to make the kind of visions or the propositions that we're making in Manchester and people are making in other places all over the world to actually make that happen. This is the kind of work that needs to be done, perhaps by you guys in your careers, from business, engineering, social development that has to do with housing, all of the design professionals, all of that work, all of those professions need to contribute to making some of these things happen, making a reality, so that we confront some of the existential challenges we face, like climate change, none more than climate change. Okay, so let me stop share at this point again for a minute and give a chance to see if there's any comments or any questions rising as I did those last few slides. Okay, so there's a couple of things here. So depending on the climate of a given area, is there the option to do quadruple mix by adding community agriculture? Oh, excellent question, excellent comment. Yes, maybe that's what we should be talking about, is quadruple. Certainly, as we talked about with the Lufa farms, and interestingly, in just this week on the news, I noticed that there was a lot of discussion of urban agriculture and a couple of different enterprises. I think it was New Leaf was one, and what were the others? There was another one that I've toured in the past and students have toured in the past. Anyway, there are at least 3 enterprises of that sort starting in Calgary now. They're not at the scale of Lufa Farms, but certainly we're moving in that direction. So yes, maybe we should be talking about a quadruple mix where urban agriculture is explicitly part of this mix as well. And in the if you get a chance to look at the designs online, that the student work that was done, often the urban agricultural aspect of it was included. So part of that 5 square kilometers is given over to agriculture, maybe on the ground level, but also consideration for the building, the construction of buildings and the design of buildings so that they can be used for vertical agriculture or for agriculture on roofs, as we saw with the loofah farms in Montreal. So yeah, really good point. And yeah, and I think the kinds of disruptions that we've certainly seen BC over the past 2 weeks, and that we've just over the last couple of days seeing in Atlantic Canada now. In Newfoundland, the Trans-Canada Highway has been washed out in multiple locations, and almost all of the goods and services that come into Newfoundland come in via the ferry and trucks at Port aux Basques, and now that route to the rest of Newfoundland is completely cut off for who knows how long. So they're kind of in a critical situation like British Columbia is now, where St. John's is on the far east of the island, and it's a 10-hour drive or almost 1,000 kilometers to get from where the ferry unloads material and trucks in Port aux Basques to St. John's, and the Trans-Canada Highway is now washed out for an indeterminate amount of time. So no material that is coming off the island is in those trucks is now moving across to the major settlements. So in that situation and what we can expect, those kinds of disruptions into the future, then thinking of local production, which is part of the Manchester concept, as well as it being a host of a local production, or another concept that people talk about these days, reshoring, which means taking the things that we've offshored. You know, we've sent almost all of our manufacturing to places like China over the last 30 years, and thinking, well, maybe it's some of that stuff we should start making ourselves. Manchester could be one of those places that seeds the beginning to create a manufacturing sector where we now again start to build, manufacture some of our basic needs. And of course, agriculture is one of those. So as we start to see more disruptions to global or even national supply chains, as the kind that we're seeing recently, then we have to get serious about developing our cities or making room in our cities to be able to manufacture and to grow these things that we need. So good point. Would it be possible, if you would see possible in Manchester community, the ability to incorporate social housing, like permanent supported housing, through a shelter or horizon housing type situation? Seems like a good opportunity, especially for the jobs that you suggest. Yes, again, good point, Nicole. There is in fact, let me see, what is it? I think it's the John Howard Society does have a new building in the middle of Manchester right now. So they have, you know, that society has thought much along the lines of what you just said, Nicole, that this is an opportunity. Because, I mean, there's a lot of things. We know that it's often difficult to get that kind of housing built because sometimes people are opposed to it. So John Howard Society saw this as an opportunity where there aren't many people living there now. So I think one of the strategies for Manchester, what we've talked about with the city, or proposed certainly as a way forward, is to make sure that these required affordable housing and social housing infrastructures are built early, so that they're almost kind of the first kid on the block, in a sense, just like John Howard Society has done, so that as you develop and as people move into the district, they realize that this is what they're moving into, and these establishments already exist. They're serving a population. They can be close to the LRT and central to the city, so access to services becomes easy. So it's a very good location for affordable housing. I just tweeted out yesterday, actually, I saw a notice just over the last week or so that the city has been putting out a notice that a huge block of, I think it was 100 acres of land, has now been made available for industrial redevelopment at the edge of the city. Can't remember exactly where it is. I think it was down in the southeast, but it was right at the very edge of the city. So what I tweeted in response to that was that this is really interesting. Why don't you think about swapping some of that land at the edge of the city for the impound lot that I pointed out on Tuesday that is right beside the LRT station in Manchester? So let's move that big, it might be, I don't know, maybe 2 or 3 acres or 4 acres of impound lot, take that and put it into this industrial district that you're just opening up, and then swap that out for affordable housing, or just a new neighborhood, mixed use neighborhood development where the impound lot now exists. And that could be the seed, using public land, because we're in a difficult situation where there's many landowners, so it's difficult to get things rolling here. But the public land, the municipally owned land, could be used as the seed to get things rolling and to take that impound lot, which again is one of these really gem opportunities in Manchester to say, why can't we do that? It's a low value use. It's a use that it's in opposition to the stated desire and policy of the city to create transit-oriented development. And here we're putting a very car-oriented land use right beside the LRT. So why not swap it out? Put the impound lot right out on the edge of the city where you've just opened up land for industrial development, and then allow the city land to become mixed-use residential compact development that is suitable for the inner city and for transit-oriented design. So yes, definitely. The other element of that, Nicole, we talked a little bit in the beginning of the term, and you remember I posted the Sustainable Calgary talk on land value capture. And Manchester is also an opportunity where land value capture can be used to seed affordable housing. So and let me explain how land value capture would work in Manchester. So for example, if you think of the 39th Avenue LRT station, it's the tracks are there. There's no big station. It's just a slab of concrete on either side, which is the platform where people wait. So there hasn't been a lot of construction happen there around the station. It's surrounded, immediately adjacent to the parking lot, or to the station, is a parking lot, city-owned parking lot. So it's kind of a park and ride kind of a situation, but it's, again, adjacent to the station is a car parking lot. And then most of the actual businesses in the proximity there are also things like auto repair and automobile retail. So, businesses that are selling automobiles. So very, very auto-oriented industrial activities and real commercial activities immediately adjacent to the LRT. Now, if the city decided to change the land use designation, we talked about the regulations as being a stopping point, the city could change the land use regulation to allow a much more intense form of development on that land adjacent to, say, within the TOD perimeter of a couple of hundred, or even within 400 meters of that train station. Then the value of the land that's now mostly low intensity uses would go up dramatically, right? So the cost of the land, or the value of that land for the landowner, would go up dramatically. Now, typically what happens is that when the city does that, and the city often does that, and we're doing it repeatedly around LRT stations, is upgrading land use so that, where before the land use said you could only build up to 3 stories, we're changing the land use so now you're allowed to build up to, say, 9 stories. And when you do that, of course, the developer who owns the land with the 3-story building on it now has a windfall, because now they can put 9 stories of condominiums on that same land. And typically then what happens is that that's great, and the landowner or the developer makes a big profit because they now can build many, many more condominium units and sell them on the same piece of land. The reason they can do that is because the city changed the land use designation. So what land value capture says is that if the city will, quote, invest in the community or in that land by upgrading the value of the land, by changing the land use designation, then the city, as an investor in that sense, should also capture some of that increased value. That value should not all go to the developer. So that's what we're, one of the things we're proposing as the city begins to look at Manchester as a place can redevelop. If you change the designation and the capacity to build more intensely on all these parcels of land in Manchester, then make sure we put in place some kind of processes where land value capture can be used to say, your land is a lot more valuable now. You have the opportunity to make a lot more money, but a part of that land value has to be put into the pot for affordable housing. And then we can go and build affordable housing on, say, the public owned land that's in that vicinity. And it can be financed by this land value capture. Or if you have 10 acres of land and we've just upgraded the value of that land, why don't you donate 2 acres of that 10 to the city so we can build affordable housing on it? So that's the idea of land value capture and how it could be used in a place like Manchester to seed the capacity for affordable housing. So there's lots of different ways to do that, but that's the land trust, setting up land trusts to be able to have affordable housing in perpetuity is one model, and that model fits very well with the land value capture. because in order to have the land trust, you have to have the land. And one of the ways that you can get the land is through the land value capture mechanism. Okay. And really it's a sharing, it's a joint venture with the private landowner. So the city is saying, we're changing the capacity to build on this land, which is increasing its value. So let's share the value that has now been created because you own the land and we've changed the designation as a public entity. Let's share the value that's now been created here. Okay. So good question. Joyce, you've mentioned district energy. What do you think about the downtown district energy? Is it built to accommodate any new buildings in the downtown? Do you think it would be feasible or worth examining to integrate individual energy systems or buildings, example, wind or solar PV, similarly with water management and rain capture? Yes, I think, I don't know a lot about the water management, but I think there certainly does, I mean, water is kind of a district water system now for the most part. But we certainly could, I think, push the envelope on that and think about whether it makes sense. I don't have the answer if it does make sense, but right now we have citywide water systems, but we could have district level systems where we do a lot more harvesting of water at a local level. Right now, the way that our water system works, and this is getting into a lot more detail, but I think it's interesting and explanation of the questions that are coming up. Gets us into some more really interesting ideas around urban design and sustainability. So right now with water, if you imagine how we've built our water and sewer systems, so excuse me, we have, typically human settlements have been built by large water bodies. They've either, been built by the ocean, like Vancouver and San Francisco and Los Angeles, for obvious reasons, because there's a lot of, you can move more easily over water, you can move stuff over water. There's a lot of, and water adjacent systems are very productive. So there's a lot of food and the capacity to grow food and catch food like fish, etc. So we've tended to build human settlements by water. And of course, we need to drink water to survive. So we do tend to live close to water bodies. So when we built water systems, large water systems in our modern cities, essentially what we've done in a place like Calgary is we tap into the Bow River and we build all kinds of pipes and dam systems so that we can dam up the water and then build pipes from those dams so that we can now put pipes all over the place through all of our districts, through all of our streets, under all of our streets, and into every home to provide water, right? And some of that is gravity because the water sources are higher than our homes. So gravity serves, often it's gravity. So in a place like Vancouver, for example, they have large lakes that are at higher elevations in the mountains above Vancouver. So most of Vancouver's water supply is gravity fed because the water is at a very much higher elevation than most of the homes. So of course the water will just flow into the homes if you build the pipes to allow it to do that. In Calgary, some of it is gravity flow, depending on where you live in the city, but a lot of it has to be pumped. So one of the biggest electricity components of the electricity bill in Calgary is actually the pumping of the water into our homes. Because we have to raise up that water. We have to use pumps to raise the water up so that it then can gravity feed into our homes, because the source of the water is at a lower elevation, because we basically just have the river as our source of our water. So that's very expensive. It's very expensive for building all those pipes, and it's very expensive for the provision of electricity to drive all of those pumps that push the water all over the place. But the kind of unsustainable element of all of that, I mean, it obviously raises the question of where you get the electricity from. And in our case, it's been historically mostly coal that has provided that electricity to push our water around. But the unsustainability or the inefficiency of the basic system is that we have a large river. When water falls on our homes, we've built stormwater systems. So stormwater systems are are built to take the water away from our homes so we don't flood. So we've built all of these stormwater systems, and we've built the eaves troughs in our houses so that when the rain falls, immediately, as quickly as possible, we get it away from our house, away from our street, and into the river, right? And that's what the stormwater system does. And there are hundreds of stormwater outfalls all along the river, both rivers, the Elbow and the Bow, in our city. And then we take that water from the river and we push it back into our homes through other pipes so that we can use that water. So you can see the inefficiency there. It's very expensive to build all of those pipes and all of that infrastructure to when the water falls on us, on our heads, on our roofs, we immediately take it away and push it into the river. Very expensive infrastructure to do that, and to make sure that we're not pushing pollutants and oils and all those sorts of things into the river alongside it. So very expensive proposition. All of that stuff that's built underground, and when you have to maintain it or rebuild it, it's very expensive because you have to dig it all up and redo it. And having done that, having gotten the water away from our homes, then we turn around and take that same water out of the river and use a whole new set of pipes to put them back into our homes. So you can see that potentially there's a lot of savings to be done, like with this more district level systems, where perhaps the focus of our activity in a place like Manchester might be just to capture the water. So one of the researches that we've done a little bit of work on and try to and continue to need to do more work on is to ask the question, does enough water fall on Manchester on an annual basis that if it was all captured, it would be enough water to serve Manchester and its use? So that has to do with the question of how much water actually falls there on an annual basis, how efficient can we be to capture that water, how much water do we use, and how efficient can we be in reducing the amount of water that we actually use. So all those questions come into play when you ask about the potential for a district water management system where we're just relying on rainwater capture and trying to eliminate so much of the expensive utility systems that we've conventionally used for decades and decades now in big cities like Calgary. And then the other element of that, of course, is sewage water or black water that runs through our toilets, et cetera, which is another huge system where we take water again out of the river, and we what we actually do is when we take water out of the river, and when it leaves our home, what we do is we mix the black water. The water has gone through our toilet with the water that's just kind of run down our sink. And that again is a very, in many ways, inefficient system sustainably, because you're taking water that is relatively easy to clean, say gray water. That's the water that, other than say toilets and showers, you're taking gray water and you're mixing it with the black water, and then it all leaves our city, it all leaves our homes, and eventually through all of the piping in the city has to make its way to the Bonnybrook treatment plant, and to be treated very expensively to clean that water so that it again goes back into the river. So then we think about whether composting kinds of systems are better implemented in the future, or again, thinking of the building in Seattle, whether we can actually at a building scale or a block scale or a neighborhood scale have these systems in place where we can actually clean and recycle the water, so it doesn't have to go through, the black water doesn't have to get mixed with the gray water, and all of that water doesn't have to travel through all the pipes in the city to a centralized facility like the Bonnybrook treatment plant to be very expensively treated and then pushed back out into the river. And in fact, they do have really good systems at Bonnybrook where they ultimately do extract the solid material from that waste stream, and most of that solid material is composted and reused in some way, put on farmers' fields, etc. So it's not, it doesn't turn into waste or garbage or go into landfills for the most part. So it's fairly efficient, that plant itself. And if you ever get a chance to tour that plant, as I've done in previous courses, it's a fascinating place as well. But anyway, so we've only talked about water yet. So then getting, Joyce, to your question too about energy, yes. The downtown system is a really good system. They, NMAX put it in place, I don't know, it might be 10 years ago or more now. It was slow to get started. And part of the reason has to do this regulatory framework again that I talked about as one of the sticking points to actually making change happen. So what happened with the downtown district energy facility is that when it was built, the understanding was, or the expectation was, that it would be the go-to solution for the East Village. And there would be some kind of a contract signed with the city to say that all of the buildings that go up in the East Village are going to be served by this district energy system. Well, for whatever reasons that I'm not completely sure about, that didn't happen. So as individual land developers bought parcels of land, some of them decided it might be a good idea to use the district system, and some of them decided, well, this is new to us, we're used to using it system where we just have our own furnace, and so we're going to just put a furnace in, and we're going to just do the normal conventional way of heating our building. And so that caused problems for the district energy, the economics of district energy, because of course they were short of customers. There were a lot of institutional customers, which is a good thing, the early adopters would say. So City Hall was one of the first buildings to be connected to the district system. The Bow Valley College was again one of the first to be connected. And over time, now that district energy system is doing very well, and there are many, many buildings in the downtown that are connected. And just as an aside in terms of what is district energy in that sense. So district energy essentially is the idea that let's build one big furnace rather than having a furnace in every building. So the district energy system is essentially a big efficient furnace. You know, in most of our homes, we burn natural gas, and the district energy site in the ENMAX site in downtown burns natural gas for the most part, although they do have the capacity to ramp up and produce heat from renewable energy sources, and hopefully that will be the wave of the future. We'll move away from natural gas. But in any event, we just have one furnace instead of hundreds. And then we have, again, piping under the ground. And what it pipes is not natural gas, but just hot water. And then that hot water enters buildings and goes through radiators, kind of like big radiators that would be big versions of what you might find in your automobile, that transfers the heat from the water in the pipes that come from district energy, and then distributes all of that heat throughout the buildings. And interestingly enough, when you look at those pipes and you insulate them, you only have about a 1% loss of energy, of the heat energy from that water from the time that it's generated at the district heating plant to the time that it delivers actual heat to buildings in the downtown. So similarly, ENMAX is actually very interested in the idea of building a standalone district energy facility in Manchester. And the interesting thing there, again, one of the interesting opportunities that Manchester presents for this kind of change is that ENMAX, the ENMAX main head offices of ENMAX and its main facility is in the geographic center of Manchester. It's right beside that image that I showed you of what used to be the go-kart track. Just to the left of that image, to kind of the east of that image, is the main facility for ENMAX. So they are very interested in pursuing that idea of district energy, and we have talked with them, and they've hosted some of the workshops for this Manchester project that I've talked about. Yeah, so there are a lot of buildings downtown. They continue to connect buildings. They're not at their capacity yet. And there's the capacity also to increase the amount of energy that can be pumped out of that facility in the downtown. And yes, it is feasible to use these district energy systems for wind and solar powered systems as well, or for PV systems, where you can take buildings with large roofs and generate more electricity from PV than you need, and you can distribute that through the rest of the district where they maybe don't have big roofs and don't have the opportunity to provide PV electricity. So yes, all of those kind of things are possible, and they're all kind of within the framework of the research that we're trying to do, because all of these things are not conventional. We've over time built our cities differently, and now we're finding that the infrastructure, the way that we have built our cities, with all of these pipes running all over the place, with the dependence on automobiles, all those kinds of things, we're finding they're not really what we need for the future, given the demise of oil and gas. And as we, again, talked about earlier in the term, oil being that very powerful, dense form of energy, we've found that, and it's been and cheap oil has allowed us to build the cities the way that we do, but there are cities that are very energy dependent. So we have to change that. These are all ideas that we're trying to suggest could be incorporated into the renovation of a place like Manchester to make that change in cities that we know needs to happen. But it's hard to make happen because we've had decades and decades of getting used to and creating systems and regulations that support the old kind of city. And there's a term in the literature that people talk about, path dependence. There's a lot of literature about the path dependence. If you read the article that I posted on a review of post-carbon cities in the Manchester project that I published a couple of years ago with Jeff Gitter, we talk about the idea of path dependence, and that's essentially what I'm talking about here. We've created a practice of how we build cities, and we've institutionalized that, and we've built up all kinds of regulations and all kinds of professional skills the development community, designers, transportation engineers, planners, urban designers have all built up a set of skills in their professions to build the kind of city that we imagined from the past, and that is kind of a sprawling car-oriented city. We know how to do that really well. To make those changes is going to be very difficult, and that's part of the idea of path dependence. We're now dependent upon the path that we've constructed over these many decades, and it is very hard to move off that path because all of these structures of society are geared towards continuing to build that same path. But we know that that path is not going to serve us into the future. So the transformation that we're in the midst of now is how do we move away from or to overcome that path dependency and do something different in the future. Okay, so path dependency is another really interesting topic if you want to check back on that, the paper that I wrote that we posted, and check out that concept as well. It's very prevalent in the planning literature. It's also very prevalent in the in business literature, this idea of path dependence. Community support, yes, a big hurdle is community support in terms of affordable housing for sure, or any kind of institutional usages, as well as any of these changes that we're talking about. What we found over the last couple of years in the city of Calgary is that there was a lot of pushback when something called Guidebook for Great Communities was created and designed over a number of years with the city of Calgary, and I was very active, as were many people, in helping the city create this Guidebook for Great Communities, which is an attempt to change the regulatory framework that we're talking about and to put in place a different framework. And in this case, it was a Guidebook for Great Communities, which is supposed to be the blueprint or the framework that would allow some of these changes of mixed use, more compact communities, more provision for active transportation in our infrastructure. All of those things were part of the Guidebook for Great Communities. Many people pushed back against it, and sadly, in this case, over the last couple of years, a lot of the pushback came from very wealthy communities who didn't want any change at all in their communities, or didn't want to see or even have the opportunity in land use designations to have affordable housing or other kinds of social housing introduced into their communities. So we do have that pushback, and that is part of the path dependence, is that many people don't like change and they're afraid of change, so they obstruct or resist change. And we'll talk about that in particular a little bit more as we get into the last couple of sessions on governance and justice and fairness in particular as a key issue. But yes, that's certainly, so all of those things are wrapped up in this idea of path dependence, where it's very easy to keep doing things the way we're doing them, and it's very hard, especially in larger and larger systems, to make changes. I mean, you can think of it in terms of on a daily basis, even your own habits. I'm sure I do, probably everybody on this call, you have particular habits that that you've been ingrained into you, that you've become accustomed to over time, and it's very hard to change that. It might be smoking, it might be using your automobile and not taking the time to say, oh, I can purchase a bicycle, and then many of my automobile trips I can actually replace with the bicycle. But these are habits that have been formed, and it's very hard to break those habits. And that's actually another really interesting area in the research, social. I'll post a little bit on it, and I also talk about it in the paper, mine and Jeff's paper. But there's a lot of academic research. It's another very interesting area that looks at this idea of the patterns that we've developed and why it is so hard to break them, and some strategies about understanding them and how we might break them. So all that comes into play. NIMBYism, people don't usually want industrial developments in their backyard, as it may not look visually aesthetic. Yes, exactly, Joyce. And that was the reason that we segregated land uses beginning in the mid 1800s in the Industrial Revolution, when it was very nasty to be living next to industrial developments. And certainly now it's much more cleaner in industrial areas, but we still have, one of the biggest things is still noise for some industries. So we have to deal with how we do industrial processes without noise, which is one of the kinds of pollution that we talk about, and in industrial ecology we try to eliminate. And in particular, those big, what I like to say, the big, dirty, dangerous, noisy trucks that you typically find in industrial areas. Nobody wants to live next to those things, but there are solutions to that. And one of the ones I introduced was this idea of moving things by rail or modular movement, so that the big trucks come to places like the logistics center, which might be in Manchester's case in say Blackfoot Trail, but none of those trucks penetrate into Manchester, and things are offloaded at the logistics center and put into smaller trucks, electric trucks, or even so many of the materials that arrive on these big trucks could actually move to their final destination with a cargo bicycle because they're just small items. So thinking in that modular terms is the kinds of strategies we have to begin to think about to avoid this idea of NIMBYism, especially in relation to living in proximity to industrial areas. So it's difficult, but it's certainly, the solutions are out there and it's not impossible. This path dependence is one of the biggest issues we have to deal with. On the topic of streetcars and pedestrians-based roads, is there a way to incorporate triboelectric friction generators into the design to collect slightly more sustainable electricity as people use the new areas? Yeah, this is another area of research. Yeah, I'm not sure exactly. I haven't heard that triboelectric before, but my understanding it is by collecting friction. So you think of flywheels, you know, in automobiles or bicycles, where the circular motion has a friction to it, and you can use motors and generators to capture some of that electricity and then use it as productive electricity. Or even people are doing, there are experiments, and it's just, there might be stretches of highway in places in the United States or in Scandinavia, perhaps, where this is actually in place and being tested on the ground as a precedent, but it's certainly not very ubiquitous. But where the weight of the automobiles or the weight of people on sidewalks is, and there's a give to the materials and the ability to actually capture that potential energy or that kinetic energy. So as a person makes a step, the weight of their body and the force of their body would put pressure on the sidewalk, and if that sidewalk was flexible and it was attached to some kind of a mechanism, which exists in technologies that can capture the movement, that kinetic movement as energy, then you can use that energy. So there's all kinds of different technologies that are in play and in development to be able to do that. There's also development of things like roadways can actually be surfaced with photovoltaic material. So you imagine all of the thousands of kilometers of roadways in the world or in our city. If some of those were coated with photovoltaic materials, and those roadways themselves are collecting solar energy. Or one of the things that there's an individual in Ramsey, just a citizen in Ramsey, who's been pursuing a project for a number of years now, to try to get the city interested in using the parking lots at the zoo and at the science center and covering those parking lots with photovoltaic panels. And that is putting kind of a shed roof, or just a roof over the parking lots and the parking stalls, and then covering those roofs with photovoltaic panels and then generating. So you can imagine, with all the parking lots in our city, if we were able to generate photovoltaic energy by having those kinds of systems in place for all the parking lots, we could generate a ton of electricity by renewable energy means. So yeah, there's like I say, with our project, we tried to avoid those kinds of what you're mentioning, Cheryl, because they're more really in the development stage, and there's not a lot of places where you can see a precedent at scale. But certainly we're on the cusp of all of those kinds of things. And the whole area of renewable energy, number one, and remember when we talked about energy, we talked about cascading energy systems, and that is not wasting energy. So another element of the district energy system is that you can capture electrical and heat energy. So typically in a conventional power plant or energy heating plant, you would in Alberta, you would take natural gas and you would generate heat, or you could generate electricity using a turbine. So there's a technology where you use natural gas You burn that natural gas and then run the steam through a turbine, and that turbine circulates and generates electricity. So then now you're using natural gas to create electricity. And that's a simple process, but the more complex process, but it's very conventional kind of a technology now as well, is that you generated that electricity. But remember, every time you use energy, you waste energy, and mostly the form of waste energy is heat energy. So if your primary purpose is to create electricity from natural gas, what you can now do is you generate that electricity, but then you make sure that you capture the heat loss that happens as a result of the frictions and everything that happens as a result of the burning of the natural gas and the pushing of that steam that's created from the burning of the natural gas through the turbine, and then the frictions in the turbine. All of that creates waste heat. If you capture that waste heat, now you have a stream of heat that you can use from that natural gas, and it increases the efficiency of use of that natural gas from maybe 50% to 80%. So you're providing electricity from that natural gas, and you're also capturing the heat of the friction in the process and the lost heat from that process to now provide heat to buildings. So all kinds of technologies that can be used to tap into renewable energies and to gather and collect energy that's typically wasted in our day-to-day lives. And now, okay, so I've seen that we have spent way more time than I thought, but this is all good questions, good conversation, lots of more things for people to track down and consider. So next day, we will pick up governance. For next week, we were going to have 2 days devoted to justice and fairness. So we'll compact those 3 days into governance, justice, and fairness next week. Take a look on Friday, tomorrow, for materials that you'll need to take a review of for next week. I may even give you some short exercises to do between now and Tuesday that relate to governance and to justice and fairness. So there might be a couple of short tasks to do to prepare us for next Tuesday. So we'll pick up governance then, and tomorrow I should be able to also provide you with the final assignment outline, so you can start thinking about that as well. So thanks for the questions today. Sorry that we did go right through this entire session and stay on Manchester, but I think some really good comments came up and some really good other, expanding the elements of there's so much to capture in this discussion in Manchester, and thinking about essentially how do we rebuild our cities from the ground up over the next 50 years. So thank you. Most people have left already. For those 7 who are left, have a good weekend, and we'll see you again next week.